This is a B-1B Lancer. It is the US military's most payload-capable bomber, and currently its only strategic bomber capable of supersonic cruise. From its appearance, the B-1B's all-black body and aerodynamic design make it look more like a fighter jet, especially when its four General Electric F-101 turbofan engines ignite. This aircraft becomes exceptionally striking. It even seems like it could go head-to-head with an F-22. The B-1B features variable sweep wings, with an angle range from 16 to 67 degrees. Wings are extended during takeoff and landing to generate more lift, and swept back during high-speed flight to reduce drag, allowing for longer range and improved fuel efficiency. This gives the B-1B both high-speed performance and excellent low-speed handling during takeoff and landing. Its Russian counterpart, the Tu-160, has a similar design philosophy. The U.S. Air Force operates a total of 62 B-1B bombers. It has the highest mission availability rate in the fleet, often taking part in real combat and exercises, most recently in operations against North Korea. In 2022, North Korea conducted 37 missile tests, launching over 90 missiles of various types and ranges. Among them was the Hwasong-17 ICBM, with a claimed range of over 15,000 kilometers, capable of striking the US mainland. The US responded strongly, which violates numerous unanimous. In November 2022, two B-1Bs, escorted by South Korean and US fighters, patrolled over the Korean peninsula, kicking off the Vigilant Storm joint drill. But the B-1B's path to service was far from smooth. The program was canceled multiple times. It was caught between two aircraft, the cost-effective, rugged B-52 and the future stealth bomber we now know as the B-2 Spirit. Sandwiched between the two, the B-1 program had a difficult time surviving. So what exactly did the program go through? How was the B-1B ultimately developed? And how did it become a core asset of the U.S. Air Force? Welcome to Chris's military base. Today, let's explore the story of the B-1B Lancer. In the late 1950s, the US and the USSR were locked in nuclear confrontation. Under such tense circumstances, both countries demanded strong nuclear retaliation capability. In the event that one side used nuclear weapons first, the other must be able to retaliate with devastating force. This concept of mutually assured destruction was meant to deter a first strike. It acted as a kind of nuclear insurance policy. So both nations invested heavily in ICBMs. But missiles alone weren't enough. After all, a missile has only two states, launched or not. Most of the time, they just sit idle. They can't be paraded around or used for deterrence. You need something that can fly around, show off strength at your enemy's doorstep. That's where strategic bombers came into play. Throughout the 1950s and 1960s, the US relied on the B-52 to carry out nuclear deterrent patrols. At its peak, fully armed B-52s patrolled near Soviet airspace 24 hours a day. The B-52 Stratofortress was a subsonic bomber and relied on flying at high altitude to penetrate defenses. As long as it flew high enough, missiles couldn't reach it. But as Soviet surface-to-air missile technology improved, high-altitude penetration became increasingly dangerous. In 1960, even a U-2 spy plane, which flew higher than any bomber, was shot down over the Soviet Union. Even the U-2 was shot down by the Soviets. You should know, the U-2's ceiling reached up to 28,000 meters, nearly twice that of the B-52. If a nuclear war broke out today, and we send in B-52s, they'd be sitting ducks. So the U.S. Air Force decided to shift its bombing doctrine toward low-altitude, high-speed penetration. At the time, radar systems were highly susceptible to ground clutter, and reflections from surrounding objects. This meant radars were effective mainly at detecting targets at higher altitudes. This phenomenon, combined with limited SAM capabilities, rendered low-flying aircraft difficult to intercept. Moreover, this also meant aircraft flying at low altitudes were hard to detect by high-altitude interceptors because their radar systems struggled to distinguish aircraft from ground reflections. Hence, low-altitude penetration became the next focus of development, especially with the emergence of terrain-following radar. With such radar systems, pilots could fly at extremely low altitudes, skimming the terrain at high speeds. So in 1969, the U.S. Air Force solicited designs for a next-gen bomber. Rockwell's proposal quickly took the lead. It incorporated nearly every advanced technology of the time. It was designed to fly at twice the speed of sound, featured specialized coatings to provide limited stealth capability, and adopted variable sweep wing technology for extended range. This design immediately underwent various wind tunnel tests to verify feasibility. A full-scale 11 mock-up was suspended from a rotating arm to test stealth angles. Its stealth performance across angles proved acceptable. As a result, Rockwell was approved to produce 3 prototypes of the bomber. After years of work, the first B-1 rolled out on October 26, 1974. Its sleek white paint emphasized its elegant contours. At the time, it was the largest variable geometry wing aircraft in the world. After its public debut, the B-1 began flight testing. It slowly taxied to the runway, took off smoothly, performed a brief cruise, and landed gracefully. Following its first flight, Rockwell launched extensive testing on the B-1. This included testing wing sweep variation during flight, aerial refueling, low-altitude penetration, and terrain-following radar trials. As the program progressed, many problems surfaced due to its complex design and integration of advanced technologies. Costs skyrocketed. Moreover, the B-1 did not meet the Air Force's requirement for ease of maintenance. It placed high demands on ground crews, and if deployed in large numbers, its long-term maintenance costs could be a bottomless pit. When Jimmy Carter was elected as president in 1976, he immediately ordered a review of the program. On June 30, 1977, he officially canceled the B-1 program. Made since I've been in office. For the last few months, Carter explained, using B-52S combined with AGM cruise missiles could achieve the same deterrent effect as the B-1. This decision met with some opposition from the military. But what the public didn't know was that due to secrecy, Carter didn't mention that. At the time, he had already begun reviewing the stealth bomber program. Rockwell's 3B-1s hadn't even begun their journey before reaching the end of the line. But fate always has surprises in store. In 1980, Carter lost re-election and Reagan became president. Unlike Carter, Reagan strongly supported defense programs. He vowed to rebuild US military power, increasing military spending to 77% of GDP. Meanwhile, the B-2 stealth bomber program ran into delays and uncertainty. No one knew when it would be ready. So with Reagan's backing, in 1982, the Air Force awarded Rockwell a contract worth $22 billion to develop and build 100 new B-1s. Several key changes were made to the original B-1 design, and the B-1B was born, optimized for low-altitude penetration. Its high-altitude speed was reduced from Mach 22 to Mach 125, while low-altitude speed was increased from Mach 0.85 to Mach 0.96. The engine inlets were redesigned to improve radar cross-section performance. Combined with special coatings, the B-1B RCS is less than one of the B-52s. On September 4, 1984, the first B-1B rolled out, painted in the iconic black livery. The B-1B immediately entered service, performing patrol and deterrence missions. A single B-1B could carry 24 nuclear warheads, totaling 12 megatons in yield. Once an alert sounded, the 4 crew members had to rush to the aircraft, remove gear locks, start the APU, fire up the engines, and take off within 15 minutes. Up front were 2 pilots, with 2 weapons officers behind them. They were responsible for navigation and weapons delivery. All crew members had to sign a statement, affirming no objections to releasing nuclear weapons during wartime. This deterrence posture remained in effect through the 1990s, until the collapse of the Soviet Union and end of the Cold War. The B-1B is 45 meters long, with a wingspan of 42 meters, powered by 4 General Electric F-101 afterburning turbofan engines. These engines are powerful. They are the heart of the B-1B. Each produces 14 tons of thrust, giving the aircraft a maximum takeoff weight of 217 tons. It can reach speeds of Mach 125. At such speeds, this massive aircraft faces extreme stress on its airframe and components, a nightmare for ground crews. In fact, after every mission, the B-1B requires up to a week of intensive maintenance in its hangar. The engines are maintained separately, removed, and taken to a specialized facility for overhaul. After maintenance, they undergo tests at various power levels to ensure proper performance. As for payload, the B-1B has 3 internal bomb bays, capable of carrying up to 34 tons of munitions. With 6 external payloads, the engines would be removed and transported to specialized rooms for servicing. After maintenance, they were tested at various power levels to ensure proper performance. This ensured the engines were fully operational. As for payload capacity, the B-1B has 3 internal bomb bays that can carry up to 34 tons of various weapons. Additionally, 6 external hardpoints can carry another 27 tons. This brings the total payload to 61 tons, twice that of the B-52, and triple that of the B-2. It can carry cruise missiles, naval mines, and gravity bombs. After the Cold War ended, the B-1B was converted from a nuclear platform to a conventional bomber. It went on to participate in multiple combat missions. In April 1999, at RAF Fairford in the UK, a squadron of 5 B-1Bs deployed to Europe. Their target Serbian military forces. At the time, NATO had begun intervening in Kosovo, launching a series of airstrikes. Unexpectedly, however, Serbian SAM forces managed to shoot down an advanced US F-117 stealth fighter, shocking NATO forces. This incident served as a wake-up call to NATO commanders. The B-1B fleet was tasked with bombing Serbian airfields, but first they had to reach their targets unscathed. Although the B-1B has limited stealth and high-speed, low-altitude penetration, radar evasion was not guaranteed. To improve survivability, each aircraft was equipped with a towed decoy system. This was a long cable trailing from the tail. The decoy, about 2 meters long, was dragged 100 meters behind the aircraft. It emitted stronger radar signals to lure radar-guided missiles toward itself instead of the aircraft, but this was its first combat use, and its effectiveness remained unproven. 3 hours after takeoff from the UK, the B-1Bs entered Serbian airspace. They descended rapidly and accelerated toward the target. Avoiding radar detection, they arrived over the enemy airfield. The B-1Bs opened their bomb bays and unleashed devastation. Each dropped 784 unguided bombs, completely obliterating the airfield. After the bombing, the B-1Bs were exposed to Serbian air defenses. They had to retreat immediately. The bombers began climbing and engaged afterburners for a supersonic escape. But just then, a SAM-3 missile was launched. The B-1B made an immediate right turn, placing its tail toward the missile, hoping the decoy would draw it away. All hopes were pinned on the towed lure. Fortunately, the towed radar decoy worked. The missile exploded near the tail. A narrow escape. The B-1B successfully evaded. The pilots credited the mission's success to the outstanding performance of the decoy. I always said that I was going to someday. And I was going to buy them all drinks. Throughout the Kosovo War, B-1Bs made up just 2 of sorties but dropped 20 of the bombs. This helped NATO execute a large-scale air campaign on Serbia and end the conflict in just 3 months. But the B-1Bs strength isn't limited to mass carpet bombing. It's also capable of precision strikes. April 7, 2003. Western Iraq. A B-1B was mid-air refueling for a classified mission. Even the crew didn't know their target. They were only told it was a high-value operation. Just 1 hour before the strike order, the CIA learned that Saddam Hussein had entered a restaurant in Iraq. He was believed to be hiding in an underground bunker there. The White House immediately authorized the strike. The B-1B was assigned the mission, but the restaurant was located in a residential area. A carpet bombing would have been unacceptable. Fortunately, the B-1B was carrying Joint Direct Attack munitions dams. To be precise, DAM is a kit attached to conventional bombs, guiding them via GPS signals. This dramatically increases accuracy. With a circular error of 5 meters, A B-1B can carry up to 24 dams, each able to strike different individual targets. Dams are also relatively cheap, only about $30,000 per unit, much cheaper than 1 million cruise missiles. Once target coordinates were confirmed, the B-1B dropped 24 dams. The bombs penetrated the structure and detonated inside the bunker. Survival seemed impossible. The restaurant was completely destroyed, leaving a crater several meters deep. Unfortunately, Saddam had already left the area before the strike. He was not killed, but the operation marked the beginning of the end for his regime. From that point, Saddam went into hiding, losing all contact with his generals. Beyond carpet bombing and dams, the B-1B has continued upgrading its arsenal to stay current. On April 13, 2018, 2 B-1Bs took off from Qatar. Their target Syria. Their mission destroy the Barza Research Center, allegedly a chemical weapons facility. Syria denied this, calling it Western propaganda. They vowed to resist with force. Meanwhile, Russia voiced political support for Syria. To avoid escalation, the B-1Bs avoided entering Syrian airspace directly. This required a long-range precision strike weapon. Specifically, the latest AGM-158 JASSM. The Joint Air-to-Surface Standoff Missile, or JASSM, carries several tons of explosives inside. It also features its own engine and wings. Sensors in the nose help guide and correct its flight path. JASSM can be launched from hundreds of kilometers away. It also has stealth capabilities, making it difficult to intercept. This marked JASSM's combat debut. 600 kilometers from Syria, the B-1B entered the launch zone and fired a 42-meter-long, 1 million JASSM. Its speed and time tow target remained classified. In the next 30 seconds, 17 more missiles were launched. After launch, the B-1B turned and exited the area. The rest was left to the JASSMs. Fortunately, the missiles hit their targets, reducing the buildings to rubble, leveling the site completely. After nearly 40 years in service, the B-1B has gone from controversial to indispensable. In every conflict, it has delivered a stellar performance. And not a single B-1B has ever been shot down. But repeated low-altitude, high-speed flights have accelerated airframe wear, leading to increasing maintenance demands to keep them airworthy. The upkeep costs have become astronomical. Thus, the U.S. Air Force plans that once the B-21 enters service on time, all B-1Bs will be retired by 2036. As air combat evolves, stealth, bay and visual range, and electronic warfare dominate. Aircraft like the swing-wing B-1B that punch through low-altitude airspace may never be seen again. The B-1B marks the end of that chapter for the U.S. But outside the U.S., Russia also developed a swing-wing bomber with similar design philosophies as the B-1B. If this video reaches 8,000 likes, next time we'll explore the B-1B's twin, the White Swan, Russia's Tu-160 Blackjack. See you in the next episode.